Hello. So back propagation of error we will discuss. The MLP training algorithm using back propagation we had discussed earlier. We will now again go through these steps of the forward computations here. So we are considering one MLP with one hidden layer. So this is the input layer. This is the hidden layer. There are two inputs x1, x2, and there's one hidden layer with two nodes. We are not considering the bias nodes here for simplicity, and we have one output node. So in the forward computations, we compute the z value, which is this value, as the summation from the previous inputs through the weights. Likewise, it would be for z22. Then z13 is the summation of both the inputs a12, a22 with the connected weights, and finally A13, which is the output, is the sigmoid of Z13. So these are the forward computations. Next step in my MLP algorithm is the computation of error as sum of squares, difference between the output and targets, and then to compute the weights connected to the output layer. So here, this we have also seen in a previous video, but I'll just simply go through it quickly for recap. So this is the error, the sum squared error difference. Then we compute the individual partial derivatives of the error with A13, of A13 with Z13 and Z13 with the weight connected to the output layer, this one. So combining all these, we get the gradient update, and we say that this value, we call it as delta 13, where delta JL is the error of node J in layer L. Okay, so the update now can be written as this delta 13 multiplied by the input which is coming through this weight A12. A12 is the input through this weight to the output node. So the gradient update can be written in this manner. So this was for the output layer. Now we come to the last step, which is the first layer weights. That is the hidden layer weights. We have only one hidden layer, so we call it the first layer weight. So now for the hidden layer, that means we are looking at this weight. With other weights also we could have seen, but we are computing for this. Again, we find out the individual partial derivatives. E with A13, A13 with Z13, say error with A13, then Z13, then Z13 with A12. This is the chain actually. A12 with W12, and finally this with the concerned weight. So these five individual derivatives we have written in this chain, this one. So del by del W1, W11 superscript 1, which is the hidden layer weight, is the product of these five partial derivatives. We write down the individual components. This we already know that we call it delta 13. So del by this whole update we write substituting this component with its delta 13, and we write down the rest of the components. We will look at it again for further simplification. Okay, so we now again look at this gradient computation for the hidden layer. So these are the five partial derivatives, and we have written the components here. Look at this red rectangle. It constitutes of delta 13 multiplied by W112. Other than this, we have A12 1 minus A12 into A11. Now we would want to write delta 1 2, error at node 1 layer 2, error at node 1 layer 2. So what is this? It is this component here multiplied by this whole delta 1 3 into W112. And then we write this gradient update as delta 1 2 into A11, which is again the input A11 coming through this weight to the node 1 of layer 2. Now we'll see the similarity of what we have done earlier. Having got this delta 1 2, we can write the gradient update in a very simple manner. Right? So this is the component from the node 1 layer 2. This is the component which has come from the next layer, because the computations are now going, these are the forward computations we show here in this picture, but in our backward propagation we are going from right to left. So we have now seen the delta 1 2 for the hidden layer, and this is the gradient update. So here we are now very clearly illustrating flow of the errors from right to left. See, we have this output node. So here the delta 1 3, which is the value is this, and this is flowing to these purple arrows to both the previous nodes. This is delta 2 2, it is flowing these black arrows, and this delta 1 2 is flowing through these arrows. So it is very nice to see how the backward propagation of error is flowing in a similar manner as the forward propagation of computations was seen to move. So this is a very nice analogy, backward propagation of errors and forward computation of the outputs. So I hope this concept is now clear to you. We'll meet again for some few more videos of simple explanations. Thank you. Thanks for watching.